Let's look at the following set. That also should review our language of sets for us. Let S be the set of all ordered pairs x comma y such that x squared plus y squared equals 25. Question. Does the ordered pair 3 comma 4 belong to S? Answer, yes. How do we know? Well, we have a test for membership. We're supposed to do what? Square each of the entries, each of the numbers, add them, and if the answer is 25, then that ordered pair belongs to S. 3 squared plus 4 squared is 25, so this pair belongs to S. How about 1 comma 2? Well, 1 squared plus 2 squared is 1 plus 4, which is 5. 5 is not equal to 25, so 1 comma 2 does not belong to S. Well, did we need any geometry to be able to visualize this result? Hopefully, one did not need any geometry to visualize this result. On the other hand, then, what does it mean in analytic geometry when we say that x squared plus y squared equals 25 is a circle? As badly as I draw x squared plus y squared equals 25 looks less like a circle than the circle I drew over here. You see, what we really mean is this. Consider all the points in the plane x comma y for which x squared plus y squared equals 25. These are precisely the points on this particular circle. And the easiest way to see that, of course, is that since the radius of the circle is 5, and the point x comma y means that this length is x and this length is y, notice that from the Pythagorean theorem we see at once that x squared plus y squared equals 25. Now again, the solution set to this equation is our set S, whether we're thinking of this thing algebraically or geometrically. On the other hand, watch what our picture seems to give us that we didn't have before. Let's return to our point 1 comma 2, which we saw didn't belong to S. Well, look at this. Where would 1 comma 2 be? 1 comma 2 would be inside the circle. Why is that? Because, you see, if we take the point 1 comma 2, if we take, say, for example, the point 1 comma 2, notice that the distance from the origin to the point 1 comma 2 is less than 5. In other words, the distance is less than 5, so the square of the distance is less than 25. In other words, not only can we say that 1 comma 2 does not belong to S, which we could have said without the picture, we can now say what? 1 comma 2 is, and notice the geometric language here, is inside the circle. In other words, the study of inequalities can now be reduced, instead of talking about less than and greater than, we can now talk about such things as inside and outside. You see, inside the circle, which is a simple geometric concept, just means what? The set of all points for which x squared plus y squared is less than 25. Outside that circle, x squared plus y squared is greater than 25. On the circle, x squared plus y squared equals 25. Again, a nice identification between numbers and pictures, analysis and geometry.